Hello and welcome in to the content video for lesson one. As this is the first lesson, I'll just explain that a little bit. So for each lesson, there will be two videos. The first one will be primarily content. Occasionally, I'll put up an example or two to illustrate a point. And then the second video will be just sample problems. And so it'll be the types of problems you're going to see on your homework, the type of problems we're going to be working in class. And so you'll have those two different videos to go through. Most of the time, the videos are maybe around 20 minutes, sometimes a little bit longer. As you'll see from the timestamp on this one, it's a little bit of a longer video. And that's because it is the most important video of the semester. You're like, wait, the first video? Yes, the first video is the most important. Let me share my document camera here with you guys. And so again, this is the content video, and then there will be a example sample problem video to follow. So the reason that this is the most important video of the semester, oops, let me move that up for you, is that this has to do with the unit circle. And so in the first day of class, if you're in my class and watching these videos, I know some of you guys from, other universities, maybe high schools, things like that, that's fine. But if you're in my class, the first day I handed out the copy of the unit circle, which we'll be looking at here in a minute as well. The unit circle is a circle with radius 1 centered at the origin And if you remember from your pre-calculus 1 classes, or maybe like college algebra classes, things like that, when we have a circle centered at the origin, it's x squared plus y squared is the radius squared. Well, because our radius is 1, we get this equation here. And so we can determine any point on the unit circle. If we're given one of the coordinates, we can just do the algebra to find the other. And so what this is going to look like, as it seems, is we're going to just have a circle that no matter where we go from the origin, it's always 1 unit out. And so, of course, out here, this is 1 unit to the right, 0 units up. This guy at the top is 0 units left and right, 1 unit up. Whoops, let's assume this touches out here. This is what? -1, 0. And down here is 0, -1. And so again, it satisfies the equation, right? X squared is 1, y squared is 0, 1 plus 0 is 1. 0 plus 1 is 1. 1 plus 0 is 1. 0 plus 1 is 1. And that is the case for anything around this circle. So these points where we end up on the circle have a name. And so where they end up, that's terminal, right? So that's our terminal points. And so to find any terminal points around this circle, we do the following. First, suppose T, so it's a terminal points T. It has this notation of T. So suppose T is a real number. We're going to start always at 1, 0. So this guy out here is always our starting point. Now, if t is positive, so t is greater than 0, we move counterclockwise. And if t is less than 0, we move clockwise. And wherever we end up, so we arrive at some point notated as pxy for our xy coordinates. And this is our value of t, our terminal point. So what I like to tell people is think of this like a park that has a big circular sidewalk around it. And so if you're going to walk all the way around in a positive direction, you're headed this way around. You could also walk all the way around in quote unquote a negative direction. So we're going clockwise. So let me put this guy up on the screen here now. I might have to zoom out so I can fit it all in. All right, hopefully you guys can see that okay. So again, this is what you got the first day of class if you're in my class. If not, and you're just watching this video as reference, you can see here embedmath.com. That's where you can print this off. And so we're going to fill this guy in. And so again, we know the point over here is 1, 0. The point up top here, 0, 1. The point on the left, -1, 0. And the point at the bottom, 0, -1. So the distance that we're going to be traveling around this circle has a name, and it's called a radian. If this is our starting point over here, again, we'll mark it in red so we know, that's our starting point. If we're going to move in this direction here, counterclockwise, so it's positive, actually let's think about this as a whole first. So if I went all the way around the circle, how far did I go? Well, that takes us back to our geometry days. Circumference of a circle. Circumference of a circle is what? It's diameter times pi. So if each of these is 1 unit away from the origin, the diameter is a distance of 2. So 2 times pi means if I started here and went all the way around the circle, I went a distance of 2 pi. But where am I starting at? Well, I'm starting at 0. So don't forget that. Everybody always forgets this, is that we're starting at 0 pi. To go all the way around would be a distance of 2 pi. So I end up back here. So if I started here, went in the positive direction, and ended up halfway around, it would be what? It would be half of 2 pi, which is just 1 pi. We have this phenomena because this track or this circular walkway, it doesn't end, right? So if I was trying to get a ton of exercise, I could go around once, that would be 2 pi. If I went around again, 4 pi. If I run around again, 6 pi, and so forth. And so we notice what? It's all the even values of pi. So if I said to you, okay, where is 120 pi on this circle? Well, 120 is even, so it's over here. So I don't have to sit there and go, okay, 2, 4, 6, 8, 10 till I get to 120. That would be insane, right? I just know that 120 is even, therefore it's over here. The same thing happens here. Let's say that my house is closer to the left side of the circle. So this is where I'm going to start walking around. Well, if this is a starting point of pi, if I go around what? 3. So if I add 2 pi to this, I get 3 pi. Go around again, 5 pi, etc., etc. So these are all the odd values. So if I started at the red, went around to this point, I went a distance of pi. If I go all the way around again, add 2 pi, so 3 pi. Add 2 pi again, 5 pi. And so that's how we know that value there. Now, what's halfway between 0 and 1? Well, half. So that means what? Up here is pi over 2. It's halfway to pi. So my basic values on the axis are 0, pi over 2, pi. And then at the bottom, it's what? Well, it's another half plus 1. So 1.5, which is 3 halves. So this value at the bottom is 3 pi over 2. And you can see the little degree things. We'll fill that in later in the semester here. But for now, we're just dealing with radian measures, which is these values of pi. All right, now let's assume I don't go all the way around, or I don't go halfway around. Let's say I start at the red and I go just to this point here, this first line. So let me make it orange. So I went to that point on the unit circle. This distance from the red up to this point is a distance of pi over 6. Now over here, the coordinate is easy enough, 1, 0, because we're right on the axis. But this one's a little trickier. But if I drew a triangle that came over to the right and came up to this guy, the distance that I would move to the right is a distance of square root of 3 over 2. And the height that I came up to get to this point would be 1/2. And so if I move a distance of pi over 6, the coordinates, the terminal point, the xy values are root 3 over 2 and 1/2. Now, let's say that instead I made it all the way to this line here. We'll leave it pink. And I'll try to zoom in. Actually, you know what? Let me zoom in right now because we're just dealing with quadrant 1. Yeah, there we go. So if this is 0 and this is 1/2 of pi, and this is halfway between them, it's what? It's 1/4 of pi, or we write it as pi over 4. And if I drew the same, another triangle down here, coming right and coming up to get to this point, both of those would have a distance of root 2 over 2, root 2 over 2. So if I was on the track walking around and got to this point, I would have gone a distance of pi over 4. But if I started at the origin, walked on the sidewalk, and then walked through the grass to get to here, I would have went a distance of root 2 over 2, root 2 over 2. And then finally, this third one, let's make it green. This is a distance, if we kind of look at it from 0 to 1 pi, it's what? It's 1/3, 1/3, 1/3. So 1/3 is what? Pi over 3. 1/3 of pi, or pi over 3. And this dimensions, if I went right and up, would be 1/2 and square root of 3 over 2. So that's our values for the first quadrant. our big three are pi over 6, pi over 4, pi over 3. If you know those, so I will give you the units, let you use the unit circle on your exams. You'll get the unit circle on the final. But you're going to use these values every day in class. So that's why I handed out the paper to you. I want you to bring it class every day until you pretty much will know these by heart. If for some reason, let's say you're whatever, out at a party and you guys start talking about the unit circle and someone says, okay, I'll give you $100 if you can tell me the coordinates for pi over 3. And you're like, ah, man, I don't have my unit circle with me. How am I going to figure this out? Well, there's a little trick. If you take your left hand, let me zoom out a little bit. If you take your left hand, we essentially get what? The first quadrant. This is my thumb is my x-axis. My pinky is the y-axis. And then pi over 6, pi over 4, pi over 3. If I want to know, well, let's look at these guys first. They all have what? They all have a denominator of 2. So that's easy enough to remember. And so then it's just, well, okay, what's in the numerator? So if I wanted to know pi over 3, and I know that it's here, my ring finger, if I close that one underneath, I have what? I have 1 and 3. Or I have square root of 1, which is 1 half, and square root of 3, so square root of 3 over 2. And as long as you know those values in quadrant 1, you can figure anything out. And that'll work with all these, right? So pi over 4 is root 2 over 2, root 2 over 2. Pi over 6, root 3 over 2, root 1, which is 1 over 2. So that works for all of those values in quadrant 1. Now, if you notice on this unit circle, and that's why I put them in different colors, this short distance here, and that has a name, we'll talk about that next, but this short distance here is the same as this short distance over here in quadrant 2. So these guys are associated with each other. You can see this line if I continue it straight through, because they're related to each other, and this one here. This one is related to each other, to the other ones. If I do the pink, well, this pink one here, if I draw it all the way through, comes down in here to quadrant 3. But because it's halfway, it's also this one and this one that comes halfway down into quadrant 4. So again, quadrant 1, quadrant 2, quadrant 3, quadrant 4, in case you need that refresher. And then what's left is my green. So this one here continues straight through. And this guy here continue straight through. And they're all related to each other. And so let's look at this orange one over here in quadrant 2. If I was to draw, do I have a ruler here? Let's see. I do not. So let me use another piece of paper. If I set this paper on here, these two guys line up directly across from each other, right? So that means if I was to draw a triangle over here to this guy, this distance over and this distance up is the same as here, root 3 over 2 and 1 half. But in quadrant 2, so in quadrant 1, everything is positive, right? X and Y are both positive. In quadrant 2, X is negative, Y is positive. In quadrant 3, they're both negative. And in quadrant 4, X is positive, Y is negative. So this orange line in quadrant 2 is the same values as the orange line in quadrant 1. So root 3 over 2 and 1 half. But here, X has to be negative. So it's negative root 3 over 2, positive 1 half. And the same holds true for the pink line. Root 2 over 2, root 2 over 2, but because x is negative, it's negative root 2 over 2, positive root 2 over 2. And the green is negative 1/2, positive root 3 over 2 for the green one in that quadrant. And I can do that for all the rest of these here. So this orange one is related to here, so it has the same values, but in quadrant 3, they're both negative. So negative root 3 over 2, negative 1/2. Negative root 2 over 2, negative root 2 over 2. And negative 1/2, negative root 3 over 2. And down here, x is positive, y is negative. So positive half, negative root 3 over 2. Positive root 2 over 2, negative root 2 over 2. And positive root 3 over 2, negative 1/2. So we have all the values now around the unit circle. But what we don't know is, okay, I know this is pi over 6, but what's this guy? Well, it's what? If I divided this whole top into sixth, 1/6, 2/6, 3, 4, 5/6, or 5 pi, because we're talking about radians here, over 6. And if I keep doing that, 6 over 6, which is 1, 7 over 6. Okay, I'm back on the orange line. So this is 7 pi over 6. And if I come around to this one, it ends up 11 pi over 6. So you can see all of these orange lines have a denominator of 6, and that's going to be important in a minute here. How about here, the pink? Well, this is 1/4, 2/4. Oh, okay, 3/4. 3/4 pi, or 3 pi over 4. And then 4, and then 5. So this down here is 5 pi over 4. 6, 7 pi over 4. And then lastly, this guy ends up 2 pi over 3. Down here is 4 pi over 3. And the last one here is 5 pi over 3. So that is when our t is positive, when we're going counterclockwise. But remember, back here, terminal points, if t, let me move that up. If t is less than 0, we move counterclockwise. So this point here, down in quadrant 4 with the pink line, is 7 pi over 4. But it's also what? Well, if I walk this way, if I walk clockwise around this track and get to this point, if I started at the red and went to here, I didn't go a distance of 7 pi over 4. I would have went 7 pi over 4 if I went the long way. So then how far did I go here? Well, because I'm going clockwise, it's negative. And the distance is how far? Well, if I go back to quadrant 1 and look, from here to the pink line is a distance of pi over 4. So from here to the pink line is also pi over 4, but because I'm going clockwise, this is also the same as negative pi over 4. And I can do that on this whole unit circle. If I go start at the red and move all the way around clockwise direction, so t is negative, and I get to this point, so I went halfway around and then to the next orange line. Well, how far is that distance really? If I go normally, halfway around plus the next orange line is 7 pi over 6. So therefore, if I went clockwise to get to this point, it's the same distance, 7 pi over 6. So halfway around plus an orange line, halfway around plus an orange line. So this is 7 pi over 6, but because it's going clockwise, it's negative 7 pi over 6. So we can find all of these values with either plus, positive, or negative values of t. Now, what if the value I give you is not on the unit circle? What if it's a giant number? And I say, okay, find the coordinates for that. Well, you don't want to sit there and keep going around and around and around and around until you finally get there, 1, 6, 2, 6, 3, 4, 5, 6, 7. That's too much work. So we have what's called reference numbers. And again, I know I said that this is one of the longer videos. If you are getting overloaded a little bit, or you kind of want to go back and look at the unit circle and, okay, do I have this figured out before I keep moving? That's fine. Go ahead and hit pause. The rest of the video will be here when you come back. Or if you need a little break just to all right, let me clear my head of math for a second before I get back on there. That's fine, because reference numbers is a very important topic. And it's how we're going to calculate these values of our terminal points throughout the semester. So reference numbers. So this has the notation T bar. Let's see here. Yeah, okay, it's reference number T bar. So it has the following definition. So let T be a real number again. So the reference number notated T bar is the shortest distance along the unit circle to reach the x-axis. Now, because it's a distance, it means what? It means it's always positive. So if I say, how far is Las Vegas from Los Angeles? It's 300 miles. It's not negative 300 miles because we're going to the west. It's just 300 miles. A distance is always positive. So our T bar, our reference number, is always positive. So let's look at our unit circle again, which you're probably going to get sick of, and that's okay. So think of the x-axis like a road. And maybe there's a bus that travels on this road, and it has a bus stop over here at pi, and another bus stop over here at 0 pi. And you're walking along and you're walking along, and you get, let's say, to this green line here, 2 pi over 3. And you look at your watch, and you're like, oh my God, I got to get the bus and get home, get dinner started. Well, what's the shortest distance? It's not headed all the way back around here, back to 0. It's just this distance from here down to the x-axis. And that distance is what? It's basically what? 1, 2, 3 lines from the x-axis. So 1, 2, 3 lines is pi over 3. Oh, look at that. Let's say you walked all the way around and you get to 7 pi over 6. Like, same thing. Oh, I got to get back. I got to catch the bus and get home and make dinner. Or I got to do my Math 127 homework. So what do? You're not going to continue around to get over to here to catch the bus. It's just like, oh, let me get back here and catch the next bus. So this distance is what? It's just a short distance to the first line, which is pi over 6. And so for you guys, for this class, that's the nice thing, because if I have any number over 3, my T bar is pi over 3. If I have any number over 4, my T bar is pi over 4. And any number over 6, T bar, you guessed it, pi over 6. So if I said to you, okay, what's the reference number for 111 pi over 4? Well, you don't have to find 111 pi over 4 in the unit circle and then figure it out. Because the denominator is 4, I know T bar is pi over 4. And it's that easy. So again, I have this quote, the essence of math is to make complicated things simple, not simple things complicated. It's not my quote, it's a quote I found. And that's what this is here. If the denominator is 4, it's pi over 4. If the denominator is 3, pi over 3. If the denominator is 6, pi over 6. So now, using this concept and using our unit circle, I can find any value I want, such as 111 pi over 4, even though it's not explicitly on my unit circle. How do I do that? So to find t terminal points, coordinates when t is bigger than 2 pi, so when it's not on our unit circle. First thing we do, find t bar. Well, that's going to be easy enough. And then 2, we find the coordinates, so we'll call it q a of b, determined by the t bar. And then finally, determine the point plus or minus a plus or minus b based on our quadrant. Where our terminal point T lies. So let's look at an example. Like I said, we won't do a lot of examples because in the second video, we're going to do a lot of examples. But just to show you what I mean by that. So let's say I want to know, so find the reference number and the terminal point AB for T is equal to 29 pi over 6. So I pull up my unit circle. I got pi over 6, 5, 7, 11. Uh-oh, 29 pi is not on here. Well, what am I supposed to do now? I don't know. Don't panic. First of all, find T bar. Well, my denominator is 6. So therefore, T bar is what? Pi over 6. So because T bar is pi over 6, that means my final answer is going to have the same coordinate values as pi over 6, which is what? Root 3 over 2 in 1/2. But I have to determine if these are plus or minus depending where t actually is. And so what I do then is I'm going to change 29 pi over 6 into a mixed number. So this is what they call an improper fraction. If you remember, how do we go from improper fraction to a mixed number? Well, we just divide it. So 29 divided by 6. Well, that's what? That's 4 with, so let's do long division so we can see. So 4, 24 with 5 left over. So 29 divided by 6 is the same as 4 and 5/6. But I have this pi here, so 29 pi over 6 is the same as 4 pi plus 5 pi over 6, if I'm converting it to a mixed number. Now, go to our unit circle, because I have all these values now. So 4 pi is what? Well, it's even, so it's over here. But then I still have to go a distance of 5 pi over 6. Well, 5 pi over 6 is what? It's over here. So from this red, move a distance of 5 pi over 6, which puts me here in quadrant 2. And in quadrant 2, I know that x is negative and y is positive. So therefore, the reference number and point for 29 pi over 6, the reference number is pi over 6, and the coordinate is negative root 3 over 2, positive half. And that's how you do those. And that's how you would do any. If this is negative, then you're just moving clockwise. If this ended up as like 3 plus pi over 6, well, when I start on the unit circle, 3 is where? 3 is here on the left. And then pi over 6 is what? It's a quadrant plus almost another quadrant. So if I was going 3 plus pi over 6, I would start here on the left and then go a quadrant plus another almost quadrant, which puts me down here in quadrant 4. So that's how you do those kind of problems. And again, we'll look at a bunch of those in the second video, the sample problem video. I know this one was a little bit long. I promise they won't all be this long. And I will see you guys in the second video for lesson 1.